Hello and hi guys, welcome to a new video. This time the problem that we're going to be discussing is called branch sums, and we have the same format today. We're going to first read the problem, understand the problem, find the complexity, how we can solve the problem. So whiteboard, discuss it, and then write a Java program for it. So let's look into the problem. It's in front of us. It's called branch sums. Write a function that takes in a binary tree and returns a list of its branch sums ordered from leftmost branch to rightmost branch sum. Branch sum is the sum of all values in binary tree branch. A binary tree branch is a path of nodes in a tree that start at the root node and end at the any leaf node. Each binary tree node has an integer value, left child or right child. Children nodes can either be binary tree node themselves or none or null. Okay, so there's a binary tree given to us. Uh, let's look into this. Okay, let me share the whiteboard so we can discuss this problem. 1 second. Yep, so binary tree is 1, 1, 2, 3, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, this is my binary tree. So basically, what they are saying is all the leaf node branch sums, right? So let's just say this is 1. So when it comes here, this will be 1 plus 2. When it comes here, 1 plus 2, becomes 3. That's the sum. The 3 plus 1, 4. Now when it comes here, 3 plus 4, 7. 3 plus 5, 8. Now 7 plus 8, 15. And okay, 7 plus 9, 16. Okay, 8 plus 10, here is 18, right? Now 4, 6, that becomes 10. 4 and 7, that becomes 11. So branch sum of all the leaf nodes. So this is a leaf node because it has got no children. Both are null. So any node where both the children are null is called a leaf node. Okay. So let's check how many leaf nodes do we have here. This is a leaf node. 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 Okay. So let's take down an array of all these numbers. So this one has 15, value 15. The other one has 16. This one has 18. This one has what? 10, the sum. This one has what? 11. And that's all. That's just your output. And they want the sum from leftmost to the rightmost, right? And in this one, you would be visiting, you have to visit all the nodes once. So that would be O of n, right? Number of nodes here is n. So, and this is your output. Now the space complexity, are we going to be storing anything? We're going to be storing, yeah, the n nodes in a queue. And then, so I'm going to do this problem. I'm going to solve it using a queue. So that would give me right to left, right? Right to left. Yeah, that would give me right to left. So I think 11, 10, 18, 16, 15. You can do it using DFS and BFS. You can solve it using, when you do the DFS, you're always going to get left to right result. And this one is going to give you right to left result. Okay. The EFS is again what? Your stack, and BFS is what? Your queue. Since we have already done an example with queue, I'm going to do it using queue. Easier. You get the idea. You guys can try with a stack yourself to get left to right. And let's write the code and look into the problem. Let's see how this would work. So I've created a tree, the same that I mentioned in the example. I've created an example tree and I'm going to bring the output. This is my method that I'm going to complete right for that, right? Ransoms. So let's just say I have a queue. T-shirt queue. Okay. A linked list. Now what I need to do is I need to not add the root element to it. That is going to be equal to 3 and while so the key contains what? Not the integer key contains but the BST. Okay, so while q is dot is empty is not empty, what do? We take if w dot right is not equal to null, right? And if it's not equal to null, then what you do is you do q dot add, right? 3 dot right to BSD to q dot full. And if my right is not equal to null, put it in the queue. Then if my tree dot left is not equal to null, you do you add q dot add dot left. Okay. Now what you do is you check if, since it's going to be, we only need the values for a leaf node, right? We're going to check if tree dot left is equal to null and tree dot right is equal to null. If both of them are null, then what you do is I'm going to create a list, okay? List dot add the, oh, I made a mistake. This is BST, right? The one I got. So it's going to be like BST dot right, BST. BST dot right. Okay. So add list dot add BST dot value, right? And what I'm gonna do is I'm gonna create a list result. The output is gonna be an integer. I'm gonna call it result. It's going to be equal to new analyst, and I'm gonna I use list here, right? So I'm gonna make it less. Now there's one more thing. How do we get the sum values, right? So anytime I add it to the queue, before adding it to the queue, what I'm gonna do is bst dot write. Okay, bst dot write dot value is equal to bst dot value plus bst dot write dot value. So I'm going to keep updating all the values so that we know what's going on, what's the recent value at that particular node. And then once this is done, what do I do? I need to update the left values as well. So BST left, uh, the left, value dot left, the dot value. Right? VST dot left dot value is equal to VST value plus left dot value at BST dot left. And then let's our BST value at the end. Just return this list and let's see what happens. Hopefully I didn't make any mistakes. So you see 11, 10, 18, 16, and 15, right? You see here what we discussed. This is left to right, but since we are using a queue, our solution is right to left. You use stack and it will be left to right. So 15, 16, 18, 10, 11, right? That's all for this video. Thank you so much for watching the video. If you have any questions, leave your questions in the comment section. I'll respond to them. And very soon I'll see you in the next video. Thank you.